Hello, math students. This is Mrs. Gillihan once again. We are working with the Mathematics Vision Project curriculum. This is Math 1, Module 1, Task 11. And we're sort of at the end of this module, and we are talking about the differences between arithmetic sequences and linear equations. And we've been working with sequences, and we've been given, throughout this entire module, we've been given situations where we have diagrams and we're asked to count dots or squares or tiles or black tiles or white tiles or what have you. And in this case, we have a diagram where the increasing number of tiles are being added with each sequence, or with each figure in the sequence. We also have a table that matches that data, and we also have a graph that matches that data. So we're going to kind of take a look at this and determine how, if we look at it as a linear equation or as a linear situation, how that might be different. Okay? So let's first take a look at the graph itself. In an arithmetic sequence and in a linear equation, the points on the graph do always land in a perfectly straight line. We notice that on the graph here we have a nice straight line. Every arithmetic sequence that we have graphed in class has been a straight line, and that is because, as we'll talk about in a minute, we have a constant rate of change, or a constant number that is being added with every possible diagram or every possible figure in the sequence. So that is important to note. It is a similarity between the two. Second is that with an arithmetic sequence we have a common difference, and with a linear equation we have a constant rate of change, also known as slope. Now, even though these are using a different letter, we use the letter D to represent the common difference, and we use the letter M to represent slope, they are essentially the same thing. Okay? When we go up 1 unit on the x-axis, we go up a corresponding number of units on the y-axis, and that happens the same whether or not you are working with it as an arithmetic sequence or if you are working with it as a slope. It is essentially the same thing. We just handle it a little differently when we're talking about how we present the equation. All right, the next thing that we're going to talk about is the input values. Here's where things really start to digress in terms of how they really do have some substantial differences. First, with arithmetic sequences, the input values are always just natural numbers. We usually, on a graph with these, we usually do not connect the points, because if we were to look at this diagram, it goes from diagram 1 to diagram 2, but there is no, for example, diagram 1.5. So when we look down here at diagram at 1.5 on the x-axis, and we kind of work our way up the graph, there is no 1.5. So there should be no points plotted or no line connectivity here. There should not be that, because input values are only considered the natural numbers. We generally do not even have a figure 0. We always start with figure 1 in an arithmetic sequence. There's not a figure 0, and therefore we don't have, like, for example, the y-intercept officially like we would have with a linear equation. So a linear equation over here, the input values can be any real number. And therefore the points can be connected. Now, sometimes there are situations where they are not in a linear equation, but the points can be connected because we can have any possible value, and a line is just a series of an infinite number of points all connected together. So in a linear equation, you can have any input value, and it does not, we are not necessarily looking at a set of diagrams, we are just looking at a series of input values uniquely. And finally, the formula itself that is used generally, which I have these backwards, let's move those over real quick. All right. In a linear equation, the formula or the equation, the linear equation that we use is slope-intercept form of an equation, y equals mx plus b. And that y-intercept is in the linear equation where it is not visible directly in the arithmetic sequence formula. The m, of course, represents the slope of the line that would be graphed. So that's a linear equation. Now, the formula that is used for an arithmetic sequence is our f of n equals the first term in the sequence plus the common difference times n minus 1. And this, as we have discussed in class, if we rearrange this, once we plunk in our numbers, we can rearrange it so that it matches what the linear equation looks like. So the linear equation is in here. They are essentially the same thing. They are just presented slightly differently. And the assumption with the arithmetic sequence is that we are starting with the first term in the sequence instead of at a y-intercept like the linear equation does.